Hello friends, today we shall discuss soil classification system, and there are in general three systems which are in vogue. One is unified soil classification system, which was proposed by Casagrande in 1943, and this is the system which is used in most of the countries including India. And another one is ASTO classification system, which is mostly used in United States of America. And the third is Indian Standard Soil Classification System, which is more or less same as Unified Soil Classification System with some minor changes. So today we shall discuss this Indian Standard Soil Classification System. Soils are classified into two broad categories. One is coarse-grained soils and another is fine-grained soil. In case of coarse-grained soil, the classification is mainly based on grain size distribution. In case of fine-grained soil, it is based on the plasticity of the soil, because the behavior of fine-grained soil depends upon the moisture content, depends upon the plasticity characteristics of the soil. When material retained on 75 micron sieve is more than or equal to 50%, then it is called coarse-grained soil. And when it is less than 50%, it is fine-grained soil. These coarse-grained soils are also classified into two categories. One is gravel and another is sand. When 50% of the material which is retained on 75 micron sieve is coarser than 4.75 millimeter sieve, 50% of material which is retained on 75 micron is coarser than 4.75 millimeter sieve. What does it mean? That material which is retained on 75 micron, half of that is retained on 4.75, 50% or more. Half of them retains on 4.75 millimeter sieve, then it is classified as gravel. Otherwise, it is sand. If it is less than 50%, then it is sand. Gravel and sand are further divided into four subgroups depending upon the grain size distribution: well graded, poorly graded, silt and clay. Well graded gravel is GW, poorly graded GP, silty gravel or gravel silt mixture is GM, and gravel and clay mixture is GC. Same is the case with sand. Sand also can be of well graded type, poorly graded or silty sand SM, or silty or clay sand SC. So there are 8 groups of coarse grained soil, and these are defined based on the grain size distribution. Now, grain size distribution of a soil, that is how we make the plot. On x-axis is a sieve size on log scale, on y-axis percent finer, starting with 0, 10, 20 and up to 100. When you make a plot, grain size distribution of a material, if it spreads like this, means the spread on x-axis is very large. That is called well-graded material. This is a case of well-graded material which basically has all sizes present in the mixture or the soil or the gravel. That is well-graded. In case of a poorly graded material, it is like this. The curve is very steep. This is poorly graded. Curve is steep. Some sizes may be either in excess or in deficiency. But all sizes are present. When a particular size is missing from the gradation, then that is called gap graded. Like this. This is a gap graded material. Now here you see from this size, let us say 1 millimeter to 0.06 millimeter or 0.075 millimeter, the percent passing between these two sizes is extremely low. So there is a gap in this distribution. So that is gap graded. Gap graded, and this is poorly graded material or soil or gravel. On this scale, up to a size of 4.75 millimeter, this is gravel. From 4.75 millimeter to 0.06, that is classified as sand. And below 0.06, it is silt and clay. That is fine grained material. That is the grain size distribution. It can be well graded, poorly graded, a mixture of gravel and silt, and similarly in the case of sand also, SW, SP, SM or SC. Now to define whether a material is gap graded, poorly graded or well graded, two shape parameters or two shape factors are important. One is coefficient of curvature, CC. CC is given by D30 square upon D10 multiplied by D60. Now here D10, D30, D60 is basically, now if this is 30%, so this is the sieve size at which 30% of the material will pass. This is D30 for this gradation. That is the sieve size at which 10% of the material will pass. 60% of material will pass. Now this coefficient of curvature should be between 1 and 3 for well graded material. Or you can say if value of CC lies between 1 and 3, then your soil is well graded. Another parameter is coefficient of uniformity, CU, and that is D60 upon D10. Ratio of D60, this is D60, 60%, that is D60. If this value is, if CU is more than 4, it is gravel. If it is more than 6, it is sand. These two parameters are important to classify coarse grained soil. So you need grain size distribution of the soil and these two parameters to define whether your gravel or sand is well graded, poorly graded, or it is silty sand or mixture of gravel and silt. So you have GW, that is well graded gravel, and in this case it can be a mixture of gravel and sand. You have GP, that is poorly graded gravel, and here predominantly one size or a range of size with some intermediate size is missing or in very low proportion. When you have the silt, it is GM. When it contains some clay material, it is GC. And same is the case with the sand also. You have SW, SP, SM and SC. Here the plasticity chart is important, and this plasticity chart as given in IS code is like this, that On x-axis there is liquid limit WL, and on y-axis it is plasticity index IP. And this, let us say, is 20, 30, 40 and up to 100 here. And this PI value is changing from, let us say, 10, 20 to 60. This is the line which is drawn at a slope of that IP is equal to 0.73 liquid limit minus 20. Let us say liquid limit in percent and IP is a number. The slope of this line, or equation of this line, which is called A line. A line. And here for a PI value of 4 and 7, when the soil lies in this range of PI value, then it is called CLML, a dual designation, CL and ML. I will tell you what is CL and what is ML. When clay or silt is present in a coarse grained soil, then the point will lie above this line, A line, and that will be indication of the coarse grained soil also. In the case of coarse grained soil, when fines are in between 5 to 12%, then that becomes a borderline case. When fines present, fines means passing 75 micron. Material passing 75 micron lies in the range of 5 to 12%, then that becomes a borderline case. So in that case, a dual symbol is also assigned to the soil, like SW, SC. The first symbol is basically gradation, that is well graded sand, and second symbol indicates the amount of clay, the clay present in the sand. So that is the nature of fines which are present here. And it will also plot above this line A. So that is how coarse grained soils are classified according to IS system of classification. Fine grained soils are classified into 4 categories or 4 groups. One is silt, clay, organic and peat. Peat is a special class of clay which is very spongy and fibrous. Silt is designated by M, clay by C, this is O and this is PT. Its behavior of the silt is slightly plastic, and they do not have any strength when it is air dried. The clay can have low to very high plasticity index, and they are very strong when they are dry. Organic soils, here organic matters are present in various sizes and in different decomposition. Peat is, as I told you, it is fibrous, having a very dark color with very high value of PI, plasticity index, and it is spongy, very spongy. Now in case of these soils also, they can also be further classified with 3 letters L, I and H. And that is the difference between IS classification and Unified Soil Classification System. In Unified Soil Classification System, this I is not included, only L and H. Indian Standard System inserted this I. Now here L basically low compressibility, I intermediate compressibility and H for high compressibility. So it can be MH, ML or MI. And similarly it can be CL, Ci or Ch, depending upon the plasticity index, depending upon the plastic in the fines. And similarly, this Ol, Oi or OH. Peat is not further classified. It is identified based on its color, its odor, its high compressibility and spongy feeling, and it is fibrous also. Now, what is the procedure to classify a fine-grained soil? The procedure is that you first find out the liquid limit, plastic limit and plasticity index of the soil. So, you know the liquid limit, that is WL, plastic limit and plasticity index. Now, once you know liquid limit and PI value, plot these points on this graph, on this chart, which we call the plasticity chart. Now, here I would put 2-3 limits, that if the liquid limit is less than 35 or 50 here, this is 50 or more than 50. If the liquid limit is less than 35, then it is in the group of L. Okay, so this is what we call Cl, and here what we call Ml or OL. If liquid limit is less than 35, and if it is 35 to 50, then this is I group. So this will be Ci, Mi or Oi. And here it is high compressibility, Mh or OH. So see how these points are plotted, liquid limit and PI value on this plasticity chart, and accordingly you classify them. So if liquid limit is less than 35%, it is Ml. In case of inorganic soil, inorganic soil means basically silt. If it is 35 to 50, it is Mi. Or if it is more than 50, it is Mh, high compressibility. If these limits plot above this line, it is the clay. If these limits plot below this line, A line, then this is silt. Now, if PI value falls between 4 and 7, then in that case it holds a dual symbol, that is ClMl. Clay with low compressibility or silt with low compressibility. There is an overlap here. If it is less than 4, it is Ml. So that is how we classify coarse grained soils and fine grained soils. Coarse grained soils mainly based on grain size distribution, and fine grained soils mainly based on liquid limit and plasticity index. Now let me take one example just to illustrate how we classify the soil. An example is like this. Let us take 3 soils, and this is the grain size distribution of 3 soils A, B, C, starting with the size 4.75 millimeter to 75 micron. This is the grain size distribution. Liquid limit, plastic limit and PI value, they are known from laboratory test. Classify these soils as per IS soil classification system. Now let us take soil A. Now soil A, if you look at this, the percent passing 75 micron is 96%. So it's a fine grained soil. So we should now look at this liquid limit and PI value. Liquid limit is 23% and PI value is 6.2%. So liquid limit is 23% somewhere here, and PI value lies between 4 and 7, and therefore it should have a dual designation, that is ClMl. So soil A is ClMl. Soil B. Now soil B passing 75 micron is 6%. So retained on 75 micron is more than 50%, 94%. So it's a coarse grained soil. Now again, if you consider the sieve size 4.75 millimeter, in case of gravel, material which is retained on this sieve, more than 50% of that should be retained on 4.75 millimeter sieve. Now here 100% is passing through 4.75 millimeter sieve. Therefore, it is not gravel. It is sand. It is a sand. Coarse grained material but not gravel, sand. And for coarse grained soil, you need to know the coefficient of curvature and coefficient of uniformity. And therefore, this should be plotted. Grain size distribution should be plotted. On x-axis, you take sieve size on log scale. On y-axis, you take percent passing and make a chart, make a plot. And from that plot, you find out what is D10, what is D30, and what is D60. So, let us say you make a plot and you get D10 is 0.16, D30 is 0.19 millimeter, and D60 is 0.22 millimeter. Calculate coefficient of curvature CC, that is D30 square upon D10 multiplied by D60. D30 is 0.19, 0.19 square upon D10 0.16 and 0.22. This is 1.03. And similarly, you calculate what is the coefficient of uniformity D60 upon D10, and this value is 1.38. Now this is less than 6. And this material passing 75 micron lies between 5 and 12%, and therefore it should have a dual symbol. So it can be either SP, SM or SW, SM, because these fines lie between 5 and 12%. Now, if you look at this, to be well graded, for a material to be well graded, this must be between 1 and 3, and this must be more than 6. Now, these conditions are not satisfied. Therefore, it is not well graded, it is poorly graded. And this is sand with silt because it is non-plastic material. So, correct classification of this soil is SPSM. Now, the third soil, if you look at this, the third soil, the passing 75 micron is 63%. So, it is again a fine grained soil. And because this soil is non-plastic, and therefore it will be a ML type. ML type soil. If you want, you can write in the bracket non-plastic. That is how you classify the soil. So thank you very much for watching this video. You can write your suggestions in the comment box.